Hello everyone, welcome to our project presentation. Our project is called Easy Meditation. We're here at Georgia Tech at Project Tech Studio in School of Music. Our instructor is Dr. Grace Leslie from the Brain Music Lab. Our group members are Phan, Carter Rogers, and me, Jiahe Qian. Our project is designed for guided meditation, and it is for potential users who will meditate every day or people who are having trouble to concentrate for ADD and ADHD patients. Right now, there are several apps that do similar things. One of them is called Calm. But one thing in common for these apps is that they don't take in any biometric data like breathing rate or any other things. And that is what set our project apart from these common products. Our product will use accelerometer in our smartphones as a data input to adjust the music being played to help meditation. The first step is being completed in Touch IC, which is a smartphone app that will transfer accelerometer data into a computer. Next, we use a software called MaxMSP for data processing. And finally, the data we got from MaxMSP is being input and mapped to control MIDI parameters in Ableton Live. Now I want to play a video to give you guys a broad sense of how our user experience is going to be like. I'm wearing a pair of Bluetooth headphones, and the music is being played to me from my computer. Now I want to talk about how we actually have our technology working to complete this whole product. So first, as I talked about, is by Touch OSC. It uses the accelerometer in our smartphones. And this data is being then input into Max and MSP. We first have it scaled down. And then we have a step called calibration. This step will take the first 12,000 samples and use it as an data to calibrate our system. Then it's going into a process called smoothing. we're using an object called ZL stream, and we're taking 10 samples and taking the average of all of them, and then output the data. This process is for smoothing the signal and prevent any spikes. After that, this is the process that we compare the output value with a threshold number. This threshold number is being set manually every time to match everybody's smartphones, because we all have different accelerometers that would accept different values. After the value was being output from the ZL stream object, it is being compared with this threshold. If it's bigger than this threshold, then we consider it a start of a breathing cycle. Finally, it is a step called limiter. We are setting our breathing rate to be more than 1 second per cycle, because that's within a reasonable range. And this limiter basically prevents any two cycles being too close to each other. And then our last step is just to calculate our data and get a period of every cycle of our breathing. And this is our breathing rate. This part is being linked with Ableton Live. So for each start of a cycle, it will trigger a clip being played in Ableton Live. There are 4 clips in total, and with every start of a breathing cycle, 1 clip is being triggered. Also, because we have the accelerometer data, we can detect the range of motion, the range of our movement. This intensity of our movement will be translated into a number that will trigger timbre changes in Ableton Live. Also, the breathing rate that we have calculated will be mapped to the tempo in Ableton Live. The sound design part is being completed in Max and MSP. As talked before, a lot of the values are being mapped to control parameters like tempo and noise and modulation part like wobble. Thank you for watching our presentation.